Welcome to qnawire.
In this problem, we have a rock and a ball, and the rock is thrown upward at 12 meters per second, and the ball is thrown upward at 18 meters per second. And I'm trying to find when they collide, and they're going to collide when their heights are the same. And so if I say that delta y for the rock is v0 for the rock times t, I'll just say t1 because our times are going to be different, plus 1/2 at squared. And the same for the ball, different v0. I'll just say v1, even though they're both initial. T2 plus 1/2 a t2 squared. This should be a t1 squared. And now I know that their delta y's is y final minus y initial, but y initial is 0, so this just turns into y. V is 0 is this, v1 is here, so I can say 12 t1, and now a is minus g, so that's 1/2 times minus 9.8 times t1 squared. And our y over here is v1, which is 18 t2 plus 1/2. Again, I have minus g t2 squared. And now I know that however long the rock has been in the air, the ball has been in the air 1 second less because the ball is thrown a second later. So now I can say that if I just call t the time that the rock has been in the air, this turns into minus 4.9 t squared. If I'm going to call this t, then the time for the ball is going to be t minus 1, because it's thrown a second later, minus 4.9 times t minus 1 squared. And now we have y's in both, so we can set these to equal. So 12t minus 4.9 t squared equals 18 t minus 1 minus 4.9 t minus 1 squared. And now I'll expand the right side. So this is going to be 18t minus 18. And now t minus 1 squared is t squared minus 2t plus 1. So we have minus 4.9 t squared, and then minus 2t times minus 4.9 is positive 9.8t, and minus 1 times, or plus 1 times minus 4.9 is minus 4.9, and now we have the t squared terms on both sides cancel. Now we have 12t, 18t, and 9.8t. And so we end up getting, 18, 4.9. If I combine all my like terms, I get 22.9 equals 15.8t. So t is 1.45 seconds. That's how long it takes for them to collide. And now if I want to know the height at which they collide, I can just plug back in here. So I'll say y equals 12 times 1.45 minus 4.9 times 1.45 squared. And so y is 7.1 meters. Now the next part, instead of the rock being thrown first, the ball is thrown first. So I can use this same system of equations that I have for the first part, except I'm going to say that the ball has time t and the rock has time t minus 1, because I'm just switching the order of when they're thrown. So I can say that y for the rock is 12 times t minus 1 minus 4.9 t minus 1 squared. And for the ball, it just becomes t, so y is 18 t minus 4.9 t squared. Right? The only difference in this part is the times are different. Everything else is the same: initial velocity, acceleration. Okay, so again, I can set these two equal. So 12 times t minus 1 minus 4.9 times t minus 1 squared equals this one. And now again, I'll expand out the left side this time. So I have 12t minus 12, and the same deal with this thing. It expands the same way. Minus 4.9 t squared plus 9.8 t minus 4.9. And now, again, the t squared terms cancel out. So if I combine these like terms and these like terms, I get 3.8 t equals 16.9. And t equals 4.45 seconds. So that's the value we get for when they supposedly collide. However, if I plug in, I'll plug into this one this time because it makes it easier. If I say the y, the height at which they collide, is 18 times 4.45 minus 4.9 times 4.45 squared, then I actually get the height that they collide is a negative number. And this means that since the ball is thrown first, the ball has the initial velocity of 18. If the ball is thrown first, and then a second later the rock is thrown, the rock will actually come down and hit the ground before the ball has to collide with it. And so if there were no ground, then the ball would eventually catch up here. This is minus 16.9 meters. But since there's ground, they just both hit the ground and they never collide with each other.